All right, if you've wondered about the theodolite, I'm going to try to run down some of the basics about it and some of the limits. Or right here, I go through and I explain what the arc seconds are at 100 feet, so you get an idea as to how accurate they are. And right here you have an old, we'd call it an antique theodolite. You have, let's zoom in a little. You have a microscope here for the vertical and a microscope there for the horizontal readings, right? The azimuth and zenith. Zenith is zenith 0. Let's see if you can even see this on this one. No, you can't, but zenith can be either vertically over your head, or it can be 0 can be on the horizontal, or you can set 0 overhead, 90 horizontal. So there's that, and then these have clamps that hold onto the plate. So it's very similar to so old style. Yeah, it's very similar to this one. Maybe we could even zoom in here. I could explain a little bit. So there's a plate in here. It's a glass plate, has degrees etched on it. So when you set this instrument up and then you turn to a back sight, you want it to be on 0. So on this instrument, what you got to do is you got to clamp the plate to the head, and then, or actually, so you set it up, and you just turn it while you're looking through the microscope to get on 0, right? And then, but you're looking at an arbitrary point. You've already lined it up with the plate, and then what you do is you clamp the plate, and then you turn that, and then it stays on 0 until you get on your backside, or whatever your backside is. It could be an arbitrary, a specific angle. And then once you've set it on that backside, then you release the plate, and then when you turn the instrument, it'll be relative to that angle, right? So the best as I can explain it. And then you have some, right here you have a mirror that lets the light in. Right, so there's no batteries on this unit. It's all done with reflection, and that's pretty much the basic idea. So vertical, so all these, what happens is you have microscopes for the vertical, for the plummet, and let's see if you can zoom in and see some of those here. There's your, so you look through this microscope here, you focus, and it bounces around and goes straight down to the point that you're above, and then that you're setting up on top of. And then this one here is the vertical, kind of bounces around, the light comes through here, hits this, reflects through this, and gives you all the angles when you look through where's the vertical, I don't know where the vertical microscope is on this. Well, usually the vertical and the horizontal microscope will be on one, and then it shows up something like this. So it's that glass plate, and you're looking through a microscope, and then it'll give you the horizontal and the vertical. You can kind of see the V there and the H there, and there you go. So this one has anyways, I don't very similar. It looks like a Nikon, actually older Nikon NT1 or NT2. We got digital. Let's go back. So this is the primary, this is the oldest one. That's called the vernier scale. You can look at that. There's an example that shows you how to read that. This is to the arc minute. So the 30 seconds, actually, yes, 30 minutes, degrees, and then, so then you have 120. So every 2 hash marks here is 1 degree. So 30, and that's why these are 30. You would just go from the 30 minutes, and then you would add the next vernier lineup of the minutes, which looks like 16, 17, something like that. Maybe they're calling it 14. Maybe that's the one that they think's lining up better. Anyways, that's how you do it. It's a vernier scale. I'm sure there's plenty of videos on that. And then all your digital theodolites are going to be very similar. So just look, if you zoom in on here, you have power, vertical angle. It's going to give you slope, or it's going to give you degrees. 0 set, kind of like the idea, right? You get on your back sight and then just hit 0 set, and it'll 0 set for you. You don't have to, or you could hit hold. Let's say you have an a specific angle, let's say it's 30 degrees, 30 minutes, and 10 seconds, you would set up your instrument, you would turn it to that, and then hit hold, and then go to that backside that's at that very specific angle, and then hit hold again, and it will just let go of it on that angle, kind of like the plate. And then right left will give you, it'll be a mathematical direction or geographical direction. So right will be from setup on 0, turn to the right, it'll be positive 1, 2, 3 all the way around to itself on 360, and then left goes counterclockwise. And then there's your function. There, I'm not sure. It'll take you different, probably different, horizontal reading, vertical reading, something like that. And then here, this one's a little different. I don't even know what instruments these are from, but you have the vertical angle, horizontal angle, and it shows you that it's horizontal angle, right? And that's in gons. So that's probably when you get into the shift key, it's going to be either gons, degrees, minutes, and seconds, or decimal degrees. Some will have the option, some probably wouldn't. Looks like you have the option to turn on a laser, so as you're shooting a line, you could see the location where it's at. Easier for your stickman to see the line. Imagine that's really useful on if you can see it, it's going to be useful. In the daytime, it would be pretty hard to see. Probably very useful for indoors and semi-shaded conditions. You got here, same thing. This doesn't tell you it's vertical, horizontal angle, right or left, but it'll give you the button to choose. So vertical, and same thing. Vertical angle will be a slope or degrees, maybe even decimal degrees and gons. And hold, same. It's gonna give you the same thing because there's no keys to type it into what specific angle you want. So you just got to turn it, hit hold, and then it'll hold you on that angle. Reset, I'm not sure, it's an icon, so probably resets it all to zeros, maybe, and then there's probably your backlight. And that's pretty much the instruments. This will give you an idea what the accuracies are, so depending on what kind of job you're doing. Zoom in a little. You have 100 foot away, 5 seconds, plus or minus 5 seconds, going to give you a 30 seconds to the right or to the left. 10 seconds, a 16th inch right or left, 20 seconds, an 1/8 right or left. So, and then there's going to be some error in it. It's systemic error in the instrument. And the cheaper instruments are going to be less accurate. The precision reading you'll see is going to be maybe within 0. In fact, you'll get a lot of 5-second instruments that'll show you the 1-second increments. So you want to kind of go into the menu or the shift key probably, and then explain that you want it to increment in 5-second increments or 10-second increments, depending on what you're doing, right? If you're staking out for dirt excavation, you don't want it on 5 seconds, right? You maybe want to set it up to 20 seconds, so you'll be much easier to hit your mark. Let's see, here we go with 30 seconds is 3/16, right? So it's about 3/16 to the right or to the left. So that's starting to get pretty good error depending on what you're doing. And 1 minute, probably just good for setting up. Depends then again what it is you're doing. You might have problems shooting accurate stuff with that. But a lot of your older instruments are going to be that. And then what you do is you end up crossing. So you'll shoot an angle from over here. You come over here, shoot an angle, close your distances, and then you can do whatever. There's just different techniques to use that 1 minute instrument and get accurate control, right? Get accurate points. So and then right here, I'm just going to show you real quick. Let's say you're set up on this point here, and then you're backsighting this direction. You can set up your backsight any way you want. It doesn't have to be pointed north. In fact, that could be problematic depending on which north you're using and the grid of the job. So you line it up with whatever grid you're using. And in this case, you're shooting here, so you would want to set your instrument to horizontal left because we're going to backsight to 0 right here. 0 degrees or 0 gons, whatever it is. So maybe I'll even hit that too. And then you're going to swing, you're going to set your instrument turning left. And then you're looking for this angle here, Alt M-A. Well, I already got it there, right? So this is the angle that we're looking for. So what you need to do is you go 23 divided by 20, and then you'll get the arc tangent to that. Tools, calculator, go 20, arc tangent, ATAN, 23 divided by 20, and then hit compute, and it'll give you that angle, 48.909, Control C. And that's what we did here. That's what I did here. I'm going to show you how to get it in case you don't know. All right, Control V. There's our decimal. So we know it's 48 degrees because there's no, it's 48 degrees. So right up here in the calculator, we're going to go minus, delete that, and then, so we just delete that, and then we get 0.9909, right? T. So we pull up the 48. And then we're going to take 0.9909. We want minutes. There's 60 minutes in a degree. So we're going to times that by 60 times 60. And we're going to get 59. .454 minutes. So we're going to go subtract, let's do this. And that's minutes. And then we have subtract the 59. We're going to multiply that by 3,600 because there's 3,600 seconds in a degree. And this is degrees, right? 490909 degrees, right? So then I hit compute and Control C. I screwed that one up. 50.454. And you get 1600. Oh, this is 59.44 is minutes, and this is a fraction of a minute, so it's only multiplied by 60. There you go. And then you end up with 27 minutes. Seconds. All right, that's how you get that. That's funny. Would have been nicer if the trial run I didn't make that mistake. But when you go to degrees, minutes, and seconds, 27 seconds, and you want to get to degrees, you're actually everything going to degrees. So it'd be tools, calculator. So it'd be 48 degrees plus 59 divided by 60. That's 59 divided by 60, that's 59/60ths of a degree plus 27 divided by 3,600, because that's 27 seconds is 27 3600ths of a degree, right? Then you hit compute and you get that 49,909. That's what that's where the 3,600 came from. Sorry. Anyways, and that's it. And then you pull, you set your backsided to 0, and then you turn that angle 49. It could be in decimal degrees, and you probably get that in a shift. Some will, some won't. Some won't give you the option to go to decimal degrees. It's all arc minutes, degrees, minutes, and seconds are gone. So, but if you are calculating with the calculator and have the option to go to decimal degrees, probably easier, less you can store it easier, and then you can go right into tangent, arctangent, and just a regular computer. And then the distance, we're going to go 23 and 20. So tools, calculator, you need to be able to turn the angle, then you need to know what the distance is from this point to that point. And then we're going to go, so square root of 23 squared plus 20 squared, close parenthesis. And that'll give us the distance. So copy that, Control C and Control V, enter. And then that's your distance, 30.4795. And there you go, that's how you do that. Maybe I'll do this so you can see it in case you need a screenshot. Square root of 23 squared plus 20 squared. Obviously you could put in just the number if you know what 20 squared is, right? And then Control C, compute, Control V. Let me make sure that I typed it in right. Enter. 30.4795, yeah, so Control V. That'll get you your distance, right? And that's pretty much it. If you were shooting back-sighting here, you'd put it into horizontal angle right, and then you could do the same thing with this angle, Alt MA. All right, so you'd be 20 divided by 23, so A10, 20 divided by 23, close parenthesis, enter. You get that 47.091, 41.0091, which is there, no degrees, minutes, and seconds. Go and just check that. .0091, and that's how you get that. If you're in Excel and you want to do that, let me just open one up real quick. If you want the arctangent to that, you have to go degree, so equal degrees, open parenthesis, atan, and then it would be, for this one, 41 degrees, it would be 20 divided by 23. Close parenthesis, and hit enter, and you'll get the 41.00909. Excel's really awesome because it carries out to 15 decimal places, even if it's just reading 3, right? So when you do your calculations, the error is so minute, almost unbelievable. Well, there you go. So you could turn an angle and pull a distance and get those coordinates, and then this here shows you the accuracy. And typically your accuracy when you're running that diagonal is going to be within 1/100th of a foot. The nice thing about that is, as you do all these points, there's no error from going from point A to point B and then from point B to point C. It's all from point A, so the error will be about the same on everything, right? Let's say if you're shooting within a 10-second, or let's say a 20-second instrument, you're going to be within plus or minus an 1/8 to the right or to the left of these points. At 100 feet, so you're going to be within your quarter for sure. Ideally, you'd want to set up, shoot some points from this side, maybe that's not longer than your back sight. Maybe come over here, check and cross check, and then hit them from the other side to close out some of those dimensions. Anyway, that's pretty much principles and what I know about theodolites that I could explain in a short video. And I hope that helps you in your career or your hobby. And thanks for watching.